Alright, for this next one, we're going to be using that same formula that we were using the other day, because we're talking about annually, monthly, and daily, and then continuously. So we're going to start with the A equals P times 1 plus R over N to the NT power. So find the time necessary for $1,000 to double if it's invested at a rate annually. First, let's do that. So here's my $1,000. I'm going to double it, so it'll be $2,000, and I'm just doing it annually, and the rate is 0.06. Annually means once per year, so I have 1 for my N, and I'm trying to figure out what T is. So it means I really have, when I divide by 1,000 on both sides, 2 equals 1 plus 0.06 over 1, which is just 0.06, to the T power. I'll end both sides. Let's go ahead and just write this as 1.06. So what I'll do is I'll be able to bring the T out front. And I'll divide. So I have ln of 2 divided by ln 1.06. So that means it approximately takes 11.90 years. Now, I'm not going to do this for monthly and daily also. The only thing that would change is in the monthly, the N would be 12, and the daily would be 365 or 366, whichever you choose. 365 is just fine. I will do it for the continuous one because you use the P equals E to the, I got that wrong, sorry. A equals, the amount you end up with equals PE to the RT. So again, we want to know how long it takes for it to double if we are compounding this continuously at a rate of 6%. So this time, I want to ln both sides. And this time I have my ln E cancels out. So I'm just dividing by 0.06. So I have ln 2 divided by 0.06. So T is approximately 11.55 years. So not a great difference there. Somewhat of a difference, not a huge difference. This next one is talking about finding exponential growth and looking at the countries and the population. So the first thing I'm going to do is I'm going to go ahead and write down the formula they want me to use. They tell me value. The K value they give me is negative 0.003. The population is 10 million that we end up with in 2007. I'm going to be doing this to predict the population in 2015. So after 7 years, the population is 10. So what I'm going to do is take 10 divided by e to the negative 0.003 times 7. That gives me my C value, which is approximately 10.21. So now I'm going to have the equation 10.21 e to the negative 0.003t, and I can now figure out what the population is at 2015. That would be after 15 years. So I'm going to plug 15 in for my time and solve. So the population would be approximately 9.76 million. Now it says, discuss the relationship between the sign of K and the change in the population is what it should say. Because K is negative, the population is going down. So you can see it was at 10 million and now it's at 9. Okay, this is my last problem for this section. We're going to start out by using y equals c e to the kt. They talk about the number of bacteria in a culture that's increasing according to the law of exponential growth. There's 125 bacteria in a culture after 2 hours and 350 after 4 hours. Find the initial population, that would be C. We have to use this information in order to figure that out. So there's 125 bacteria after 2 hours. So I could say that C is equal to 125 over 2K. And that's not 2K, that's E to the 2K. Then what I'm going to be able to do is use the second piece of information and say 350 equals CE to the 4K, because after 4 hours there's 350 bacteria. That allows me to put that value in for C. So I have 350 equals 125 E to the 2K times E to the 4K. Well, that will simplify to be 125 e to the 2k, because I would subtract those exponents using the law of exponents. Then what I'll do is divide by 125. 350 divided by 25, or 125, reduces to be 14/5. Now I can ln both sides. And that allows me to say that k is equal to the ln of 14/5 divided by 2. K is approximately, when you plug that in your calculator, 0.5148. Now I can go back to my original problem over here where I was using 125 bacteria. I can put in my K value being 0.5148, and then divide that off. So when I divide by e to the 2 times 0.5148 on both sides, that ends up giving me the C value of 44.64, approximately. So I have found part A. That was my initial population. Part B says write an exponential growth model for the bacteria population. That would just simply be y equals my initial 44.64, e to the k, my k value we found to be 0.5148, and then t is how the time is changing. We're supposed to use the model to determine after 8 hours. So I will plug in 8 for my time. And when you plug that into your calculator, you will get an approximate answer of 2,744. And then for the last question, it says after how many hours will the bacterial count be 25,000? So for that particular part, I'm going to have to say, well, when will it reach 25,000? So I'll say 25,000 equals 44.64 e to the 0.5148 t. I want to solve for t. So I'll divide by 44.64. I will then have to ln both sides. So that leaves me with t being approximately, once you take this divided by 0.5148, you get 12.29 hours. I know a lot of this is using your calculator, so make sure you're practicing using the calculator.